All right, people. I believe everybody is doing great, nice, and absolutely fine. So, welcome to Unacademy Neet English. And guys, let me know in the chats if I'm perfectly audible, visible to each and every single student. Everyone means everyone. I need to know in the chats if I am perfectly audible, visible to each and every single student. Okay? And let the people join, let the people come. We are going to smash these short topics, okay? And the topics that I'll be covering in this particular, we say, session, you can expect the questions in your NEET 2025 examination, okay? And I'll be starting from the scratch. Doesn't matter if you have studied these topics before, doesn't matter if you have studied these chapters before, but I'm going to start from the scratch, okay? You would be able to understand every single thing. That's great. That's great. Guys, make sure you smash the like button because liking the session is marking the attendance. That is very much mandatory. Everybody out there, smash the like button. Okay. So people have joined. People have joined. So I know anxiety level is increasing day by day. We are moving closer to the NEET 2025 examination. So guys, before this, I would want you guys to do one thing. What is that? What is that? That is. This is my Telegram channel. That is t.me/YAWAR MANZOOR. Guys, I would want you guys to join this Telegram channel, okay? Because every single thing, whatever it is, okay, the PDFs, we say the notifications, every single information I share in this Telegram channel only. Okay, so do join this Telegram channel. You can search it in Google also. You'll land onto this, my channel, that is t.me/Yawar Manzoor, YAWARMANZOOR. Now, guys, let's start the topic. Okay, let's dive into this particular session. Let's dive into this particular session over here. Okay, let's dive into this session. Okay, let me now start. Now, guys, make sure you have marked the attendance by liking this session. Guys, first and the foremost topic that we need to understand in this one is what we call the angular momentum. Extremely important, okay? When it comes to the JEE mains as well as NEET. When it comes to the JEE mains as well as NEET. Guys, see, take a look. What does angular momentum mean? Before starting the angular momentum, let's talk about linear momentum. Guys, we say, let's suppose if we have a mass over here which has some velocity. There is a mass which has some velocity v. We say this mass will have momentum p is equal to mv. This is the linear momentum of a mass. Okay, yes. Now guys, so when a mass is in motion, we say it has momentum. Now let's take a look at this mass over here. Let's take a look at let's suppose this mass, this is the mass which is moving, okay, with the velocity v. I'll define 2 points over here, guys. I'll define 2 points. One point is this, another point is this. This is point A and this is point B. Guys, always remember, when we talk about the point A, with respect to the point A, I want you guys to focus exactly over here. With respect to the point A. With respect to the point A. Guys, this mass is moving in a straight line, linearly. With respect to the point A, it is moving linearly. So with respect to this point A, it will have linear momentum, P is equal to mv. But when we talk about the point B, we say with respect to the point B, guys, with respect to the point B, this mass is moving angularly. See, it is creating an angle theta over here. Okay, when it reaches over here, so it is cutting some angle. So with respect to the point B, mass is moving angularly. With respect to the point A, we say mass is moving linearly. So I can say with respect to A, it has linear momentum. With respect to the point B, it will have angular momentum. So we always define angular momentum with respect to any point, okay? Like here. This is the mass. With respect to the point B, it is moving angularly, okay? Okay, it is cutting some angle. But with respect to A, it is moving linearly. So with respect to point B, it will have angular momentum. If you ask me, sir, what is the value of that angular momentum? what is the formula for that angular? How much will be that? That is going to be L is equal to mvr sine theta. M is the mass, V is the velocity, okay, and R is the radius, okay, R is this radius. Now, you say sine theta. Theta is the angle between R and V. Usually, my dear friends, we take this radius, we take this perpendicular radius. This is, if this is R, this is theta, this is R cos theta, this is R sine theta. Directly remember, guys, when I say angular momentum, that is mvr sine theta. Or you can write it like this also, L is equal to R cross mv, or L is equal to R cross P. Cross product of linear momentum and we say radius factor will give you the angular momentum. So this is the angular momentum of a translating body, pure translating body. If this body is moving with respect to this point, it will have angular momentum, that is mvr sine theta, or we can say R into R cross mv. Yes. Now, guys, we can define it like this also. As I told you, this mass is moving with respect to point A, it is moving linearly. With respect to point B, it is moving angularly. If this is R, this is theta. Can I say this will be R cos theta? Yes, this is going to be R sine theta. Guys, we usually take which component, which is perpendicular. We take this perpendicular, okay, perpendicular component of R. We will not take R cos theta. Why? Because with respect to this, it is moving angularly. So we take this component, this velocity, okay, R is equal to mv R perpendicular. This is the perpendicular component over. Or you can also say L is equal to mr v perpendicular. Simply, guys, if there is an object which is moving angularly with respect to the another point, it will have angular moment. And that angular momentum is mvr sine theta. That's it. This is the formula that we are going to use. And this is the angular momentum of a translating body, which is moving. See, this is moving linearly. Okay. And if there is an object which is doing the rotational motion, like this rod, it is rotating about this axis. Like this rod, it is rotating about this axis. Okay, this rod. Sir, what is the angular momentum of this? We say its angular momentum is I into omega. Its angular momentum will be I into omega. I is its moment of inertia. Okay, and omega is the angular velocity. Like you can compare it with P is equal to mass into velocity. Here you have angular momentum L, here you have linear momentum in linear motion. Here you have moment of inertia, here you have mass, here you have angular velocity, you have linear velocity. This is the difference between rotational motion and translational motion. This is the difference between rotational motion and translational motion. Yes. Now guys, see, let's suppose if you have this rod over here, which is rotating. What is the, remember directly, sir, moment of inertia of a rod about an axis which is passing through its center of mass. So it is going to be ml square divided by 12, because we say L is equal to I into omega. Okay, so this will be ml square divided by 12. That is moment of inertia about this axis into omega. This will be its angular momentum. Okay. This will be its angular momentum in this particular case. Now guys, so we got to know two formulas. One formula is angular momentum of a translating body, pure translating body, that is mvr sine theta, and second one is angular momentum of a purely rotating body, that is I into omega. Now let's take a look at the question. See guys, an object projected with speed u. We have projected an object with speed u. Okay, we have projected an object with speed u. Take a look, guys. We have launched or projected an object with speed u. Okay, this is the speed u. At an angle theta, this angle over here is theta, at an angle theta, with the horizontal. Find the angular momentum when it is at the maximum height. Guys, when it is at the maximum height, we know that vertical component of the velocity is 0. Always remember this. And horizontal component remains same. That is if it is launched with the velocity u, that will be u cos theta only. That is u cos theta only. Okay, yes. And at this maximum height, guys, this is going to be the maximum height. Okay, maximum height. So we have to find the angular momentum at this topmost point over here. Okay, Now, guys, tell me one thing. Can I say when it comes to the angular momentum? Okay, so at the topmost point, it is mv, and then we say mvr, and then I say sine of theta in this particular case. Yes, simple, simple. mvr sine of theta in this particular case, or because we say, if you'd say this is r cos theta, this is r sine theta, so you can directly say this is mvr perpendicular, because you take the perpendicular component. Yes. Now tell me, here in this particular case, always remember, when it comes to the velocity at the topmost point, it is u cos theta. When it comes to the r perpendicular, guys, this is going to be the r, this will be r cos theta, this will be r sin theta. So r perpendicular in this case will be the h max. That is the maximum height of a projectile when it is at topmost point. That is u square sine square of theta divided by 2g. Okay, this is the maximum height of a projectile. Now put it over here. Put it over here. Can I write this angular momentum is going to be, that is m. What is the velocity in this case? Velocity is u cos of theta. Okay. And then what is the r perpendicular? That is the maximum height. That will be u square sine square of theta divided by 2. Divided by 2. Okay. Okay. So this is going to be the angular momentum at the topmost point. This is going to be the angular momentum at the topmost point of a projectile in this particular case. Okay, of a projectile in this particular case. Okay, because at the topmost point we know it is u cos theta. Okay, okay, and this will be r perpendicular. That is what we are supposed to say. Is that clear, guys? Is that clear? Tell me in the chats, everybody out there. Give me the signal in the chats. Is this clear? Now, guys, take a look. There is a question which this question is important. Okay, this question was asked in J Mains 2025. An object of mass m is projected from the origin in vertical xy plane at an angle of 45 degrees. Same question. See, guys, here it says we have launched an object, okay, at an angle of 45 degrees. This is 45-degree angle, okay, with the x-axis. And initial velocity with is u naught, okay. The angular momentum with respect to the origin, when it reaches the maximum height, guys, when it is at the maximum height, what is going to be the angular momentum, guys? I have recently told you the formula for the angular momentum, okay, that is mvr perpendicular, okay. Now, can I say over here, angular momentum is going to be, that is mvr perpendicular, mvr perpendicular, yes. Now, in this case, at the topmost point, velocity is going to be, that is, if this is v naught, this is v naught cos of 45. Okay, because horizontal component of the velocity remains constant, vertical velocity will be 0, and this is going to be the maximum height. This is going to be the maximum height. Okay, that is r perpendicular. This is r perpendicular. Now, guys, we can say v cos 45 is 1 by root 2. So this is going to be v divided by root 2. That is the velocity. And when I say r perpendicular, that is v naught square, u square sine square theta by 2g. So that is v naught square sine square of 45 divided by 2g. So you can write it like this: v naught square sine square 45, that is 1 by root 2 whole square, that is 1 by 2. So it is going to be 4g. Because when I say sine 45, that is 1 by 2, its square will be 1 by root 2, its square will be 1 by 2. 2 into 2 becomes 4, it is v naught by 4g. Now, guys, what will be the angular momentum? That is m. What is the velocity v? V is v naught divided by root 2. Then we say r perpendicular, that is v naught square divided by 4g. So we can further write v naught square into v naught. So we can say m into v naught cube divided by 4 root 2 g. This is going to be the angular momentum at the topmost point. Now, guys, with the fire emojis, let me know in the chats if both of these questions are crystal and clear. So the formula for angular momentum of a pure translating body, that is this one, mvr sine theta. And we take which component? We take this perpendicular component when we write the angular momentum. Okay, because r sine theta is which component, guys? If this is r, so we say this is theta, this will be r cos of theta, and this will be r sine of theta. So instead of r sine theta, I am saying L is equal to mv r perpendicular. That's why I'm saying this one, mv r perpendicular. That's it. That's it. We consider the perpendicular velocity. So L is equal to, or you can say in case of cross product will be this. Now for the purely rotating body, it is L is equal to I omega. Yes, that's great. Okay. Now guys, solid sphere is rotating with the angular speed omega. Find the angular momentum. Guys, what is the angular momentum over here? I into omega. Sir, what is the angular momentum over here? I into omega. Okay. Now here, this is going to be 2 by 5 mr square, because moment of inertia of a solid sphere about an axis which is passing through its, we say, center of mass, we say that is going to be 2 by 5 mr square, and then we say omega. Here angular momentum is going to be 7 by 5 mr square, where m is the mass, r is the radius. Okay, okay, into omega. This will be the angular momentum. This will be the angular momentum in both the cases. Another topic is conservation of angular momentum. We say extremely important when it comes to the conservation of angular momentum. Extremely important, yes. Now guys, take a look. Take a look over here. Guys, when it comes to the Newton's second law, how many of you have seen this formula? F external is equal to dp by dt. Rate of change of linear momentum with respect to time is the external force. If I say net external force on a body is 0, so this will become 0. 0 into dt will become 0. So dp, change in momentum, dp means change in momentum, is 0. So means momentum is conserved. Momentum is conserved means initial momentum will be equals to the final moment. Initial momentum will be equals to the final moment. Okay. Because when momentum is constant, conserved, initial momentum is final. In case of angular moment, in case of this rotational motion, we say a rotational version of Newton's second law is tau net is equal to dl by dt. Here it is force, here we have torque. Here it is linear momentum p, here we have angular momentum dl by dt. So net torque is equal to rate of change of angular momentum with respect to time. Now if net torque on a system, on a body is 0, so this would become 0, dl by dt will be 0. So dt into 0 is 0, so dl will be 0. So if change in angular momentum is 0, angular momentum is conserved. So final angular momentum is equal to initial angular momentum. Simple. Final angular momentum will be initial angular momentum. Let's take a look. Question asked in JEE Mains 2024. JEE Mains 2024. A thin circular disk of mass m and radius r is rotating about an axis. Okay. Guys, there is a disk over here. There is a disk over here. Okay. This disk. It is rotating about an axis. Okay. Okay. Its mass is m and radius is r. So we say, let's suppose its angular moment of inertia is I. Okay, this is a disk, its moment of inertia is I. Then this is initially. And it says it is rotating with angular velocity omega. Then if we talk about finally it says, if another disk of mass m by 2, we say this disk. Okay, we say this disk. Okay. If another disk of mass m by 2, if another disk of mass m by 2, okay, this is, I would say over here, m old disk, this is m divided by 2, is placed gently on the first disk, okay, is placed gently on the first disk coaxially, then the new angular velocity of the system will be, okay, you have to find what is going to be the new angular velocity. Guys. Initially, moment of inertia is I. We can say here also, this is the old disk, its moment of inertia. This is the new disk we are adding. So its mass is half, So moment of inertia would be half. Yes. Now, when it comes to this system, there is no net torque. Net torque on the system is zero. If net torque on the system is zero, angular momentum initial is angular momentum final. What is the initial angular momentum? I into omega. What is the final angular momentum? Guys. We say finally moment of inertia is going to be I plus I by 2. I plus I divided by 2. I can write over here. So this will be, that is 2I plus I divided by 2. That is 3I divided by 2 in this particular case. Okay. 3I divided by 2 in this particular. Now, my dear friends, tell me final angular momentum, that is I into final angular velocity, final moment of inertia, that is 3I divided by 2. Okay. And final angular velocity is omega dash. So I and I will cancel. So this is going to be 2 omega divided by 3 will come out to be omega. Okay. This will be the angular velocity of the new system when you add m by 2 mass disk to it. Okay. Take a look here. This was the question which was asked in Neet 2017. Two disks of moment of inertia rotating about their regular axis passing through the center of mass perpendicular to the plane of the disk with the angular velocity omega 1 and omega 2. Here angular velocity is omega 1, angular velocity is omega 2. And this is initially something like this. Initially. And finally it looks something like this. This is finally. Initially and finally. Okay, initially and finally. Now guys, just a second, guys. Okay, so finally it looks something like this. Okay, so with the angular velocity omega 1 and omega 2, they are brought in contact face to face. So basically, these two disks are brought in contact face to face, coinciding the axis of rotation, The expression for the loss in kinetic energy during the process, very important. Okay, guys, it is a kind of collision. See. These two disks are coming and they are colliding. It is like you have got mass, you have got another mass. This is mass m1, velocity v1, mass m2, velocity v2. They are colliding. So, guys, I want you to remember this particular formula. We say loss in kinetic energy. Okay, loss in kinetic energy. If two masses are colliding, I have told you over there in collisions, it is 1 by 2 m1 m2, 1 by 2 m1 m2 upon m1 plus m2 v relative square. Okay, this is how we find the loss in case of the collisions, this formula. Now, in case this is the linear motion, in case of rotational motion, guys, loss in kinetic energy is going to be 1 by 2. Here it is mass m1 m2, here it is moment of inertia I1 I2 upon we say I1 plus I2 omega relative square. And what is omega relative, guys? In this particular case, directly remember this formula. Omega 1, omega 2. This is the angular velocity. Okay. This has got, we say, I moment of inertia. This has got moment of inertia I. So I1, I2, I into I divided by I plus I is 2I. Now this I and this I will cancel. Omega relative is omega 1 minus omega 2 whole square. So we said this and this will cancel. It will come out to be I divided by 4 omega 1 divided by omega 2 whole square. So basically, this equation is important. If you have to find the loss in kinetic energy in case of rotation, this equation I want you to remember directly. Like you do in the collisions, same is in case of this rotation over here. JEE Mains 2010. A circular ring of mass m and radius r is rotating about its axis with the constant angular velocity omega. Okay. So there is a ring over here. Its mass is m and its radius is r. It is rotating about its axis with the angular velocity omega. Okay. It is rotating. two particles of mass m are attached gently on the opposite ends. Guys. This ring, we are attaching a mass on this. We are attaching a mass on this on the opposite sides, okay, of the ends of the diameter of the ring. The new angular velocity of this system will be new angular velocity. Guys, in this particular case, we say net torque on the system will be again zero. Okay. Now tell me. Guys, here. We say angular momentum is conserved. Initial angular momentum is equal to final angular momentum. Initially, the state is something like this. Okay, that will be I into omega initially. Okay, finally, it is going to be I dash into omega dash, final moment of inertia, final angular velocity. Initially, when I say moment of inertia of a ring, that is mr square into omega will be. And finally, guys, finally, you have got this mass. So moment of inertia of this mass plus the moment of inertia of the ring. Okay. So I can say finally, what is the moment of inertia of this mass and this? What is the final mass in this particular case? Okay. Mass of this disk, that is m. Okay. So we say when it comes to the final moment of inertia, for this it is mr square, for this it is mr square. We say 2mr square plus moment of inertia of the ring, that is mr square. Okay. And this one is small m, this one is small m, this one is small m. What just happened, bro? Let me show you here this. Initially, its mass is m, it is rotating with the angular velocity. Initially, L initial is going to be m into r square. Then we say finally you are attaching a mass over here, you are attaching a mass over here. This is small m, this is small m. Now it is rotating with angular velocity omega dash, this is radius r. So when it comes to the final angular momentum, that is mr 2 times of mr square. Okay, because for this mr square, for this mr square. Then we say plus moment of inertia of the ring, that is mr square. Okay, and then we say omega dash over here. So in this particular case, what we can write is that is mr square will be equals to 2 times of mr square plus capital M into r square over here. Okay, and then we say omega dash. This r square and r square will cancel over here. Okay, what else can we do? Guys, we can say in this particular case it is m is equal to, we say 2m plus this m into, I would say, omega dash. So omega dash will come out to be m upon, take this in the denominator, this will be 2m plus, we say, this m. So this is going to be the final angular velocity in this particular. Okay, just simply conserve the momentum. Okay, what about this one? Guys, tell me the answer of this particular question quickly. Tell me the answer of this particular question quickly in the chats. Okay, quickly in the chats. L, okay, omega is also here. Omega is also here. Okay, and it is omega here, it is omega here. Because guys, it is I into omega is equal to I dash into omega dash. This is going to be. Yes. Guys, is this clear? Please tell me in the chats. Is this clear? Please tell me in the chats. Everybody out there. Is this clear? Give me the signal in the chats. Is this clear? Give me the signal in the chats, guys. Is this clear? Initial angular momentum is equal to final angular momentum. That's what I'm doing. Okay. Initial angular momentum is I into omega. Its moment of inertia of the ring is mr square and angular velocity is omega. Finally, there will be moment of inertia of this mass plus ring, that is twice mr square plus moment of inertia of the ring into omega dash. Now make this equal to this. So then we did the cancellation, we got this one. We got this one. Great. What about this one, guys? A disk of moment of inertia, I2 about an axis perpendicular to its plane passing through its center is placed on another disk of moment of inertia I1 rotating with omega. Okay. About the same axis, the final angular velocity of the combination is this. I am giving you as homework, and I have solved a lot of questions on the same topic. So I would want you guys to comment its answer. Comment its answer later on. Comment its answer later on. What is going to be the answer in this particular case? Next question. Next topic we have over here, that is escape velocity. Okay. We say the minimum velocity with which you can escape from the gravitational field of Earth. Guys, if we say this is the Earth over here, this is also an important topic. If we say this is an Earth over here, its mass is m and radius is r. There is an object present over here on the surface of Earth. Now, if you are launching this object with the velocity vm, now due to this velocity, if I say, guys, let me show you. Let me just give you the feel of escape velocity over here. Take a look. Let's suppose this is Earth. You are throwing an object in the air and it falls back due to the gravitational pull. Now I'm saying give more velocity. Now you are giving more velocity, again it comes back. Now you are giving more velocity, again it comes back. Now you are giving more velocity, it does not come back, it goes to the infinity, out of the gravitational field. This velocity with which an object goes out of the gravitational field is called escape velocity. Okay, it is called escape velocity. And this escape velocity has two formulas. Okay, in terms of mass, it is under root of 2gm by r. Then we say in terms of density, that is r under root of 8 by 3 g rho pi. Okay, r under root of 8 by 3 g rho pi. Okay. So this is also the escape velocity in terms of density, in terms of mass. Now take a look at the question over here. The ratio of escape velocity at Earth to the escape velocity at the planet whose radius and mean density is twice. Guys, there is a planet, radius of that planet is 2 times radius of Earth. This question I have shown you in the last class also. Okay, then we say density of the planet is given as 2 times density of Earth. Yes, density of planet is 2 times density of Earth. Now we are supposed to find the escape velocity. Okay, ratio of escape velocity. Now guys, when it comes to the escape velocity, it is r under root of 8 divided by 3. We say rho pi, and then we say g. Rho is the density, pi is pi, g is the universal gravitational constant. Guys, we said g is constant, pi is constant, 8 by 3 is constant. So velocity is proportional to r, and we say then rho. Now if they ask you to find the escape velocity at Earth divided by escape velocity at the planet, so you guys will write it like this: r under root rho. R means radius of Earth. So we say that is radius of Earth is re, under root of density of Earth is rho e. And then we say radius of planet, that is 2 times re under root of density of planet, that is going to be 2 times rho e. Now this rho e cancel, re cancel, so it will be 1 upon 2 root 2. This is going to be the ratio. Okay, what about this one? The escape velocity, guys, take a look over here. The escape velocity of a body from Earth is about 11.2 kilometer per second. Okay, assuming the mass and the radius of Earth to be 81 times the mass and radius of the moon. Guys, tell me one thing. When it comes to the escape velocity, we say on Earth, it is under root of 2 gm by r. It is in terms of mass. Escape velocity is under root of 2 gm by r. See, escape velocity is under root of 2 gm by r. Now, if we talk about this escape velocity on the moon, how can I write this? This would be under root of 2 g. Mass of moon, it says, mass of Earth, it says 81 times the mass of moon. So means mass of moon is 81 times less as compared to the mass of Earth. So mass of moon is going to be m divided by 81. Yes. So it would be like this, m divided by 81, then divided by radius of moon is, okay, radius of Earth is 4 times radius of moon. So we say radius of moon is 4 times less as compared to this r divided by 4. So it would be under root of, guys, can I write it like this? See. It would be, we say 2gm divided by r, I can write like this. Then this would be 4 divided by 81 if I do the reciprocal. Now, root 4 divided by 81, that is 2 divided by 9. And this is under root of 2gm divided by r. And this is the escape velocity on Earth, that is given as 11.2 kilometer per hour per second. So escape velocity at the moon is 2 divided by 9 into, instead of this is the escape velocity at Earth, that is given as 11.2. Okay, solve this and get, it will come out be 2.48. Okay, is this clear? Give me the signal in the chats. Everybody, guys, tell me quickly, guys. Okay, so this will come out to be 2.48. Okay, kilometer per second. Okay, now this I'm giving you as homework. This already I have shown you in the last class. Simple, bro. The radius of the planet is twice that of the Earth. Its average density is same. Here density is given as constant. Now, if the escape speed of the planet at the Earth is Vp and Ve, escape speed on the planet, escape speed on the Earth. Now tell me, what is the formula for escape speed? That is a radius under root of 8 divided by 3 rho g pi. Okay. Now here 8 by 3 is constant, rho is constant, g is constant, pi is constant. So velocity depends upon radius only. Now it says if the radius of the planet is doubled, if you double the radius, we are back, guys. Let me know if we are back. Guys. There was some internet issue. Please tell me if we are back. Yes. I believe so. It's fine now. Okay, that's great. Let's move now. Let's move on to the next topic. Okay, this question is extremely important, guys. That is, electrical force between the 2 point charges is 200 Newton. If we increase 10% on one charge and decrease 10% on other, the electrical force between them for the same distance becomes. Take a look, guys. Take a look, guys. Let me make you understand this particular topic. Extremely important. Yes. Take a look, guys. It says that electrical force between the 2 point charges 200 Newton. Electrical force between the 2 point charges 200 Newton. You have got a point charge over here, or there is a sphere. It has got the charge Q. And this is a sphere. It has got the charge Q. Distance between the two spheres is, we say, R. Okay. And force between them, this force is given as, we say, 200 Newton. And if I say, how do you calculate this force? You say K Q1. We say K Q square divided by R square. Okay, because K Q1 Q2 by R square is the force, and this is given as 200 Newton. Now, what does it say? If we increase 10% charge on one of the charges, if we increase 10%, guys, right now it is how much? It is 100%. Q means complete Q, 100%. If you increase 10%, what is going to be the charge? It will be 110%. Directly remember. Already it is 100%. If you increase 10%, it becomes 100%. 100% of Q. 100% of Q. Okay. Previously it was 100% of Q. Now it becomes 110% of Q. How do we write 110%? Guys, we write it like this: 110 divided by 100. This is how do we write 110%. Then we say Q. This and this will cancel. So it will come out to be 11 by 10 Q. 11 Q divided by 10. So means if there is a charge Q, you are increasing 10% charge on this, new charge will become 11 Q divided by 10. What is Q2? Then it says decreases 10% charge on the other. You are decreasing here. Previously it was 100. Now if you decrease, it will become 90%. So we say 90% of Q. And how do we write 90%? That is 90 divided by 100 of Q. This and this will cancel. So it is 9Q divided by 10. It is 9Q divided by 10. Okay. Now guys, if I say, if you place this charge over here, okay, if you place this charge over here, that is 11Q divided by 10. If you place this charge over here, that is 9Q divided by 10. Okay, and distance between the two is R. If I say, what will be the new force between them? Sir, F is equal to K. Q1, that is going to be 11Q divided by 10. Then we say 9Q divided by 10 divided by, we say, R square. Okay. Now guys, how can you write this? You'll be writing over here 9 into 11 is 99 divided by 100. Okay. Then we say KQ square. KQ into Q is Q square divided by R square. KQ square by R square is given as 200 Newton. So it would be 900, and this is F dash, new force. 900. It would be 99. 99 divided by 100 into, this is given as 200. This and this will cancel. 2 99s are 198 Newton is going to be the new force. 198 Newton is going to be the new force. Guys, tell me in the chats quickly if this is crystalline clear to each and every single student. Tell me in the chats quickly if this is crystalline clear to each and every single student. Tell me. Simply, if this is a charge Q, this is a charge Q. You are increasing 10%, you are decreasing 10%. It would become 110%, it would become 90%. Let me show you the question which was asked in Neet 2019 on the same topic. 2-point charges A and B having charge plus Q and minus Q respectively, okay, are placed at certain distance apart, okay, and force acting between them is F. Guys, this is charge Q, this is charge Q, okay, and it is plus Q and minus Q. This is plus Q and this is minus Q. This is minus Q. Okay, if 25% charge of A is transferred to the B, so we are transferring 25% charge over here. Find the force. First, What is going to be the force between them? K q square divided by r square. This is going to be the force. Now, if you transfer 25%, guys, it is 100% already. If you decrease 25%, how much is remaining? 75%. We say here it is going to be, we say Q1 will remain 75% of Q. So it is going to be 75% means 75 divided by 100 Q. Okay, 25 threes are, 25 fours are. So it would become 3Q divided by 4. So new charge is going to be 3Q by 4. Now tell me, this is, guys, this is 100%. So if you are transferring 25%, this is already minus 100% of Q. Now, if you are adding positive 25%, what is going to happen, guys? Plus minus 100 plus 2500. Don't you think that here it will be minus 75% of Q? Yes, minus 75% of Q. So we say new charge here is going to be, that is minus 75% of Q. Because you are adding positive 25%. So that is going minus 75 divided by 100, and this is Q. This is 3s are, this is 4s are. So minus 3Q divided by 4. This is going to be minus 3Q by 4. Now guys, first charge is 3Q divided by 4. Second charge is minus 3Q divided by 4. Distance between them is R. What is going to be the new force, sir? K. Q1, Q2. That is 3Q by 4. And then we say 3Q divided by 4 divided by R square. Okay, how can you write it? Guys, 3 into 3 is 9. 4 into 4 is 16. So 9 divided by 16. Then we say K. Q into Q is Q square divided by R square. So we say this is F dash. New force F dash will come out to be 9 divided by 16 of F. Is this clear? Please tell me in the chats. Is this clear? Guys, smash the like button. Smash the like button, and most importantly, join this Telegram channel, okay? That is t.me/YAWAR MANZOOR. This is my Telegram channel where I share notes, every single thing, PDFs, every single thing. Okay. Can you do this question? 50% of, see, it says that you have got a charge Q. You have got another charge Q. Distance between them is R. It says 50% of the charge is transferred from this charge to this charge. If 50% charge is transferred, we say how much remains over here? We say 50%. 50% of Q. What will be the charge on this sphere? It is going to be 150% because already 100% was there. If you transfer 50%, it becomes 150%. Okay, now you can solve this question from your end. Okay. This concept. Take a look. Take a look. Take a look, guys. When we talk about this concept, find the value of minus Q if the system is in equilibrium. You have got the 4 charges on the corners, okay? And there is a negative charge present over here. You have to tell me what should be the value of this Q, and the entire system is in equilibrium. When I say entire system is in equilibrium, means this charge also in equilibrium. Net force on this charge is 0. Net force on this charge is 0, on this, every charge. Okay. Let's consider one charge. Okay. Let's find the forces on one charge. Guys, see. What is going to be the force on this charge? So this will repel it with the force F is equal to K Q square divided by, if this side is A, so it would be A square. Okay. This will repel it with the force F is equal to K Q square divided by A square. If this side is A, we say this would be root 2A. This will repel it with the force, I would say, this is F dash, that is going to be K Q into Q is Q square divided by, what is the distance? That is root 2a. That is going to be root 2 of a whole square. And this will be kq square divided by 2a square. Kq square divided by 2a square. Now, this negative charge will be attracting it, sorry, towards itself with a force, let's suppose F double dash. Okay. Now, this F double dash force will be, that is. I'll write it over here. This would be F double dash. And that is going to be K, this charge Q divided by distance between them. Half of the diagonal is A by root 2. So that is going to be A square divided by 2, because A by root 2 whole square is A square by 2. Now guys, listen to me very carefully. These are the forces acting on this particular charge. Now, can I say in this particular case, resultant of this one and this one, it would be something like this. Guys, it is kq square by a, and angle between the two is 90. We know if the angle between the two forces is 90 degrees, resultant is root 2 of that force. So this resultant is going to be root 2 kq square divided by a square. Now guys, forget about this one. These are the two forces acting from the lower side. These are the two forces acting from the upper side. Balance the two. So this, because why? Because this charge is in the equilibrium. Upward force is equal downward force. So upward force is kq divided by a square by 2. It will be equal to this force plus this force. That is a root 2 kq square divided by a square plus this. That is kq square divided by 2a square. Okay. Now, what can you cancel in this particular case? We say k and k, q square and this square. Okay. Even this a square, and this a square, this will go in the numerator. This will become 2q is equal to. From this side, it would be a root 2q plus q divided by 2. Yes. Now do the cross. Okay, take the q common. So 2q will be, this capital Q is common. This would be root 2 plus 1 divided by 2. Now this q will come out to be q divided by 2. Take this q over here. Now this is 2 root 2 plus 1 divided by, we say 2. 2 into 2 is 4. Q will come out to be, that is q divided by 4. 2 root 2 plus 1. So basically the concept is, this is the answer, and it is charge is negative, so put the negative sign. The concept is, if they say the system is in equilibrium, consider any charge. I'm taking this and balance the forces on this charge. Check how many number of forces are acting, balance those forces. Like similar type of question over here. You have to find the value of this charge. Okay, the system is in the equilibrium. Find the force, consider any charge, this one. We say force here is F is equal to K, Q1, Q2, that is Q square divided by A square. This will repel it with the force F is equal to K, Q square divided by A square. Okay. So this will repel it with this force. This will repel it with this force. Now guys, this will attract it with the force. That is F is equal to K, Q into Q divided by, distance between them is A by root 3. In case of a triangle, it is A by root 3 from the centroid to the corner. So A square divided by 3. Now, resultant of this one and this one, this angle is 60, because if this is 60, this is 60, this is 60. If this is F, and this angle is 60, resultant is going to be root 3 of kq square divided by A square. Okay, this is kq square by A square, kq square by A square, resultant will be root 3 kq square by A square. Now you guys tell me, guys, what is the force on this charge from the upper side? That is kqq divided by A square by 3. It will be equals to, that is a root 3 kq square divided by A square. That's it. This will cancel. Q and this square will cancel. So this will become 3q. Even A square will cancel. 3q will be equals to root 3 into q. Now this, we have to find the value of this. Q will be equals to root 3 divided by 3 into q. Is negative. Guys, give me the signal in the chats. Is this clear? Is this clear? Everyone means everyone. Tell me, guys. Is this clear? The concept is simple. You take any charge, balance the forces on it. That's it. Then you will get the value. Then you will get the value. Let me know in the chats with the fire emojis if everything is clear. Why negative, sir? Because then the charge is negative given over here, na? Then only net force will be 0. If this was positive, so this will be also repelling. How then this net force on this charge will be 0? How is it? How come is it possible that this will be in the equilibrium? Center charge has to be negative. Okay, let's talk about this one. See. Electric field due to the segment of ring. This is not a complete ring. This is some part of the ring, segment of ring. Okay. Now, lambda is the charge per unit length, and this is the radius. This is the radius. Join one end of the ring, join another end of the ring. This is the radius, and this over here is theta. We say electric field due to a segment of ring is 2k lambda by r sine of theta by 2. 2k lambda by r sine of theta by 2. Okay. Now this is the general formula. This is the general formula. When I say in case of a semicircle, guys, if this is a semicircular ring, this is the radius r, this is the radius r. So angle between these two radius, this is 180 degree. Theta is 180. Now, guys, when I say electric field will be, that is 2k lambda divided by r sine of theta by 2, that is 180 divided by 2, that is sine 90. Sine 90 is 1. So it will come out to be E is equal to 2k lambda by r. Next, due to a chord, okay? So basically, this is a complete circle. This is a semicircle. This one is what we call the chord. In case of the chord, we say theta is 90. Now, guys, we say over here, theta is 90 degrees. See. Use this general formula. Use the general formula. E is equal to 2k lambda by r sine of 90 by 2. That is sine 45. So this will come out to be 2k lambda by r. Sine 45 is 1 by root 2. Now I said multiply with root 2 and divide with root 2. Rationalize. Root 2 into root 2 becomes 2. That will cancel with this 2. So it will come out to be root 2k lambda divided by r. So you have to remember this. Electric field due to a chord, that is root 2k lambda by r. Electric field due to a semicircle, that is 2k lambda by r. Electric field due to a segment of ring, that is this. What if I give you a question something like this? Guys. If, let's suppose, this angle I am giving as 60 degrees or 120. Let me give 120. Theta is equal to 120. Okay. Find the electric field due to this. Find the electric field due to this. What will you say? E is equal to 2k lambda divided by r sine of 120 divided by 2. That is sine 60. Sine 60 is root 3 by 2. So 2k lambda divided by r. Then we say root 3 divided by 2. 2 and 2 will cancel. Root 3k lambda divided by r. Yes. This is how we find the answer here. Okay. Guys, what is the answer to this? See, here half of the chord is filled with positive charge, half of the semicircle is filled with positive charge, half of the semicircle is filled with negative charge. See guys. I want you to divide this in two chords. We say electric field due to this positively charged chord is away from the chord. Okay, that is root 2k lambda divided by r. Because electric field due to a chord is root 2k lambda by r, since the charge is positive, electric field due to a positive charge is away from the charge. Electric field due to negative charges towards the charge, this will be also root 2k lambda divided by r. Now angle between the two is 90 degrees. So basically, if you have one vector, root 2k lambda divided by r, if you have another vector, root 2k lambda divided by r, okay, and angle between the two is 90. We say in that case, resultant is going to be root 2 of root 2k lambda divided by r. Okay, that is root 2 into root 2 is 2k lambda divided by. This would be 2k lambda divided by r. To all the lovebirds in the chats, did you guys smash the like button? Okay, because I can see the chats over there. What is your ID? Okay, let's exchange the ID. I'm sending you the text. You are not replying. First, like my session. Okay. Yeah. Now, guys, take a look. Session will not be too long. Okay, 1.5 to 2 hours. Okay, 1.5 to 2 hours. Now, guys, what about this one? So basically, this is a ring, and this is positive charge. This is positive charge over here. Okay, and this is negative charge over here. So half of the semicircle is filled with positive charge, half of the semicircle is filled with negative charge. So due to a semicircular ring, electric field is, we say 2k lambda by r, 2k lambda divided by r. Due to this also, electric field will be 2k lambda by r. Guys, see, due to a negatively charged ring, electric field is towards the ring. Due to a positively charged ring, electric field is away from the ring. So here net electric field, if we say, that is 2 plus 2 is 4k lambda divided by r. Okay, and direction is downward, and direction is downward. And direction is downward. Yes. And what about this one, guys? See. You can divide this in 4 chords. You can divide this in 4 chords. So this is negatively charged chord, electric field will be towards. This is negatively charged chord, electric field will be towards. This is negatively charged rod, electric field will be towards. Due to this positively charged rod, electric field will be like this. Guys, this electric field is cancelled with this. Now. Here, we say this is the electric field due to negative charge. This is the electric field due to positive charge. Both are in the same direction, so they'll add up. So when I say net electric field, that is electric field due to negative charge. That will be how much? Due to a chord, it is root 2k lambda divided by r plus. Due to this chord, it will be root 2k lambda divided by r. So that is going to be 2 times of root 2k lambda divided by r. Simple. Okay, flux. It says that, guys, what does the flux Gauss law? It says that flux through any closed surface is charge enclosed divided by epsilon naught. Means, if this is a sphere over here, inside this sphere charge is present Q. We know, sir, field lines will come out of this charge because a charge creates electric field. Now, field lines are crossing the surface, so flux will be created. How much will be this flux? Flux is charge inside divided by epsilon naught. That's it. Whatever is the charge inside divided by epsilon naught. Guys, see. In this particular case, we say you have got a cylinder over here. Charge is present over. If the charge was present here, enclosed, I would have said flux is Q by epsilon naught. But charge is present at the mouth. Charge is present at this mouth. So what we do is that we attach one more imaginary cylinder. Okay. Now, guys, this charge looks like an enclosed surface, an enclosed charge. Now tell me, flux through any closed surface will be Q divided by epsilon naught. Yes, but here this closed surface is made up of 2 cylinders for this charge. For this charge, we say this is made up of 2 surfaces. So it would be flux through 2 cylinders. Okay, so flux through one cylinder, it will be Q divided by 2 epsilon naught. So because flux through 2 cylinders is Q by epsilon naught, Flux through 1 will be 1 half of q by epsilon, that is 1 by 2. Yes. Okay, take a look here, guys. In this particular case, you have got this cylinder over here. You have got this cylinder over here. Okay. It says if the flux through this surface is phi naught. Okay. Let's suppose flux through this curved surface is phi naught. So basically, cylinder is made up of 3 surfaces. We said 2 plane surfaces, 1 curved surface. Flux through curved surface is phi naught. What is the flux through this plane and this plane? Guys, see, we say flux through closed surface. That will be, here closed surface is made up of 3 surfaces, 2 plane surface plus curved surface. So that is flux through 2 plane surface plus flux through curved surface. Now, this is flux through a closed surface. How much is this? This is q divided by epsilon naught is equal to flux through 2 plane surfaces. This we have to find out. Flux through 2 plane surfaces plus flux through a curved surface, that is given as phi naught. So take it over here. Q divided by epsilon naught minus phi naught is equal to flux through 2 surface. Okay. Now, if you have to find the flux through 1 plane surface, guys, flux through 1 plane surface, that is, this is flux through 2 plane surfaces. Through 1, it would be 1 half of q divided by epsilon naught minus, we say, phi. Okay. Yes. Guys, let's suppose a rod is placed something like this inside a spherical ball. You have to find how much is the flux. Guys, first of all, you have to find the charge inside this. Okay, let's find charge inside the closed surface. Let's find charge inside the closed surface. Tell me one thing, guys. If you have to find the charge inside the closed surface, first of all, you have to find this length. Guys, tell me one thing. If this is r, this would be also r. Consider this as x. Okay. Now use PGT in this triangle. PGT is hypotenuse square. Hypotenuse square will be equals to base square, that is r square by 4. Base is r square by 4 plus perpendicular square, that is x square. Now take it over there. R square minus r square by 4 minus r square by 4 is equal to x square. Now this is 4r square minus r square, that is 3r square divided by 4 is equal to x square. Now take it root over there. So x will be over here under root of 3r square divided by 4. That is root 3r divided by 2. Now this is the length, this much length. And this much length will be also x. So that is 2x. So 2x is going to be 2 times of root 3r divided by 2. This and this will cancel. So this will be root 3 of r. This is the length. Now, guys, you might have studied one single thing. That is lambda is equal to charge divided by length. So take this over here. Q will be lambda into L. So charge inside is going to be, guys, lambda. Because lambda for this length is given, for this charge is given. And length is how much? Root 3 into r. This is the charge inside. First, I calculated the length. After calculating the length, I used lambda is equal to q by L. From that, we got the charge. Now, we say flux through a closed surface. That is q inside divided by epsilon naught. Now, what is q inside? That is root 3 lambda r divided by epsilon naught. This is flux through a closed surface. This is flux through a closed surface. Is this clear? Please tell me in the chats, guys. Is this clear? Please tell me in the chats. Everyone. Now, take a look. Take a look, guys. Take a look. If you, let's suppose, have a cube, okay, and inside the cube charge is present, how much will be the flux through the through the entire cube because there's a closed surface. That is Q by epsilon naught. Flux through the cube is Q by epsilon naught. If I say what is the flux through one phase, guys, this Q by epsilon naught is the flux through 6 phases because this closed surface means flux through 6 phases. That is Q divided by epsilon naught. If I say how much is going to be flux through one phase, that is Q divided by 6 epsilon. Yes. Okay. Now, if the charge is present at this mouth, so you have to attach one more. Now this becomes an closed surface. So now flux through two cubes will be Q by epsilon naught because this closed surface is made up of two cubes. So flux through one cube will be Q divided by 2 epsilon naught in this case. If the charge is present at the corner, how many more cubes you need to attach so that this becomes an enclosed charge? 7 more, so total of 8. So flux through 8 cubes will be Q by epsilon naught because 8 cube means flux through closed surface. For this charge, how many more cubes you need to attach? 7. Okay. So total is 8. That is Q by epsilon naught. Now flux through one cube, it is going to be Q divided by 8 epsilon naught. Okay. And flux through one face is going to be Q divided by 24 epsilon naught. Flux through one face in this case will be Q divided by 24 epsilon. One more question. See guys, there is a concept that is work done is equal to change in potential energy. So if you do the work done on any body, we say its potential energy will be changed. I want you guys to remember this directly over here. Work done is equal to change in potential energy. Like I'll give you the example. If you have an object over here on the surface, its potential energy is 0. Now, if you lift this object, you place it over here. We say here its potential energy is mgh. Where does this potential energy come from? When you lifted the ball from the surface till height h, we say its potential energy is increased. You did the work done. Due to that work done, potential energy changed from 0 to mgh. That's what I said. Work done is equal to change in potential energy. That's it. Now take a look. If I say these are the 3 charges placed at the corners of a triangle. If we shrink this triangle, okay, if we bring the charges close to each other, how much is the work done by external agent? Guys, see, we say work done is going to be change in potential energy. Work done is going to be U final minus U initial. Final potential energy. Guys, if you have to write the potential energy of this system, we write potential energy between the pairs first. Sir, potential energy between these two, between these two, between these two. That is, sir, potential energy between these two charges. That is K Q square divided by A by 2. Now, between these two also it will be same. Between these two also it will be same. So I'll write 3 times. So 3 into 2 is 6kq square divided by A. What is the potential energy initially? Guys, between these two charges, it is kq square divided by A. Now, how many? This pair and this pair, total of 3. Now, how much is going to be the work done? Final potential energy minus initial potential energy. Final is 6kq square divided by A minus initial is 3kq square divided by A. So that is going to be 3kq square divided by A. This will be the work done. Okay, this will be the work done. There is one more question also on the same topic, which I have shown you in the last class also. It says that this is a hexagon. Here positive, negative, positive, negative, positive. 6 charges are present. If you take this charge from center to infinity, how much will be the work done? Work done is change in potential energy. Work done is final potential energy minus initial potential energy. Guys, finally charge is at infinity. So at infinity, we assume potential energy as 0. Now we have to find potential energy initially. Initially, charge is present here. Guys, see. First, you write the potential energy between these two charges, then these two charges, then these two charges, then these two, then these two, then these two. See, when I write over here initial potential energy, understand this very carefully. U initial. First, we write between the positive charges, okay? That is K, this Q naught divided by If this is D, this would be also D divided by D. Now, this is between two positive charges. Here also similar positive charge, here also similar positive charge. So this will be 3 times. Then write the potential energy between this Q naught and negative charge. That is minus A Q and Q naught divided by D. Now, between these two, and between these two, this is also 3 times. This and this will cancel, this will be 0. Okay. Now, tell me, work done in this particular case is U final minus U initial. This is 0, work done will be 0. This was the question which was asked in NEET 2022. Okay. There is one more question on the similar concept that I'm giving you as homework. Common potential. Very important. Very important concept. Take a look, guys. Common potential or midpoint potential. I want you to understand this very properly. Let's suppose you have a resistance over here R1, you have another resistance over here R2. Potential of this end is V2, potential of this end is V1. You have to find the potential of this common end. Directly remember, potential of this midpoint will be V1 divided by R1, V1 by R1 plus V2 divided by R2. Okay, then we say 1 upon R1 plus 1 upon R. That's it. That's it. Now, here. We say you have to find this midpoint potential. How do you write? Sir, V1 by R1 plus V2 by R2 plus V3 by R3. Then 1 by R1 plus 1 by R2 plus 1 by R3. Done. Let's take a look at this. Guys, you have a circuit over here. You have to find the current in this branch. Okay. What you are supposed to do is, if you have a circuit like this, always remember, assume 0-volt potential at a point. We are assuming 0-volt potential at this point. Okay. If you assume 0-volt here, how much is the potential difference of the battery? 20. So here it is going to be 20 volts plus 20. Why, sir? Because one end of this battery is 20 volts. This end should be how much? Difference is 20. Always remember, if let's suppose we say this is 10-volt battery. This is point A, this is point B. Always remember, we say this VA, potential of this end minus potential of this end is always equal to this potential difference delta V. Now, if I say this is 0, this is 20, how much should be this? 20 minus 0 must be equal to this 20. If this is 0, this is 10, how much should be this? This is 10 volt plus 10. Not minus 10, it should be plus 10. Why? Because 10 minus 0 is equal to this 10. Difference of these 2 points must be equal to this. If this is 20 over here, this will be plus 20 because it's a straight wire. If this is plus 10, this would be plus 10 over here. Now redraw this diagram. So it will look like this. So this is 10 ohm, this is 20 volt. This is 10 volt, this is 20 ohm. This is 5 ohm and this is 0 volt. You have to find the potential of this midpoint. Now tell me, guys, can I say midpoint potential is going to be V1 by R1, that is 20 divided by 10, plus V2 by R2, 10 divided by 20, plus V3 by R3, 0 divided by 5, upon 1 by R1, 1 divided by 10, plus 1 divided by 20, plus 1 divided by 5. Okay. Yes. Now, guys, this will come out, solve this will come out to be 50 by 7. Now you have to find the current in this branch. Now take this branch only. Potential of this is 50 divided by 7. Okay. And potential of this is plus 10 volts. Okay. This resistance over here is 20 ohms. You are supposed to find out the current in this branch. Guys, we say current is delta V divided by R. Because Ohm's law, V is equal to IR. Delta V divided by R. Okay. Now tell me, this current will be delta V is higher potential minus lower potential. 10 is greater than 50 by 7. 10 minus 50 divided by 7, R is 20 ohm. This will be 70 minus 50, 20 divided by 7 into 20. This and this will cancel, it will be 1 divided by 7 ampere. So current in this branch is 1 by 7. Even you can find the current in this branch also. Okay. Even you can find the current in this branch also. That is, this is 20 volts. This resistance is 10 ohms. And this is over here 50 divided by 7. This potential, midpoint potential. Now current will be delta V by R. That is 20 minus 50 divided by 7. R is 10. Solve it and get the current. Let's suppose we have this question. You have to find the current here. You have to find the current here. Guys, potential, we don't have to assume 0 anywhere over here because it is grounded. This means here it is grounded. So means here potential is 0. If this is 0, here also it will be 0. Now if this is 8, how much is this potential difference? This potential, that is 8 volts plus 8. Why? Because 8 minus 0 must be equal to 8. Higher minus lower, this is always higher, higher minus lower. Now if this is 8, this is 4. How much potential should I place over here so that the difference must be 4? You say, sir, we put 0 over here. 8 minus 0 is 8, but here it is 4. So 0 is not the correct. Let's put 4 volt over here. 8 minus 4 must be is equal to 4. 8 minus 4 is equal to 4. Okay. Now if it is 4 over here, it is 6. How much should I place over here? Minus 2 volts. Now see. Higher minus lower. 4 minus of minus 2 will be equal to 6. See, it is matching. This is how we need to play with the circuits. Now guys, you got the potential across the ends. See. Can I say current will be delta V divided by R? Delta V is higher potential minus lower potential. 8 minus of minus 2 divided by R is 2. So this is 10 divided by 2, that is 5 ampere. 10 divided by 2, 5 ampere. Is this clear, guys? Smash the like button. Okay. Let me show you one more on this. Okay, here. You have to find the current in this branch. Do one thing, redraw this circuit. Shift this from this side. Sir, can we do it? Yes, no problem. We'll make it something like this. Do one thing, shift it from this side. So this will be the resistance. This is going to be the battery. This resistance, this battery, and this battery, something like that. So what I did is that I exchanged the position of this and this. This is 20 volts. This is 5 ohms. We have to find the current in 5 ohm resistor. This is 4 ohms. This is 10 volts. This is 8 volts. Guys, what I'm trying to say in this particular case is assume 0 volt potential at a point. If this is 0, here also it is going to be 0. Here also it is going to be 0. If this is 0, this is 8. How much will be this? This will be plus 8 volt. Okay. If this is 0, this is 10. This is 10. Guys. If this is 0, difference is 10. How much will be this? This will be minus 10 volts. Sir, why minus 10? Because this side is this longer one is the higher potential. We say higher minus lower. Now see, 0 minus of minus 10. That is going to be plus 10. That's why we say this is minus 10. This is 0. This is lower side. This is higher side. So this is plus 20. Okay. Now if this is 8, this is 8 volts here, straight wire. Here also it is going to be plus 8 volts. We were supposed to calculate the current in this wire only. Now see, take this only. This is 5 ohm. From this side, it is 20 volts. From this side, it is 8 volts. Current is going to be delta V by R. That is higher potential 20 minus 8 divided by R is 5. 20 minus 8 is 12 divided by 5 amp. I hope you are loving this. Okay, I hope you are loving this. Okay, I'm showing you each and every single point. Is this clear? Please give me the signal with the fire emojis. Everyone. Galvanometer. Important from current electricity, because when it comes to the electrostatics and current electricity, 10 questions are asked. Take a look. Guys. Galvanometer. Okay. Galvanometer is a device which is used to detect the current. Okay. It also measures the small range of currents. It cannot measure the large range of currents. It can measure the small range of currents. And galvanometer has its own resistance. We show the galvanometer something like this. This is G, and this is the current which flows in the galvanometer. This is the maximum current which can flow in the galvanometer. G is the resistance of the galvanometer. Okay. Conversion of galvanometer into ammeter. Directly remember. Guys. If this is a galvanometer, you connect a resistance parallel to it. This is called shunt resistance. So, when you connect a shunt resistance parallel to the galvanometer, it becomes ammeter. That's it. Ammeter measures the large range of currents. Galvanometer measures the small range of currents. How do you convert galvanometer into ammeter? Connect a resistance, shunt resistance parallel. Now, if I current is flowing in this system, so we say Ig will flow in the galvanometer because this is the maximum current which can flow in the galvanometer. If you send more current than this, it will burn out. So how much will be the current this one? That is I minus Ig, and this is the shunt. If somebody says what is the value of shunt? Ig into G. Ig is the current in the galvanometer. G is the resistance of the galvanometer. I minus Ig. Let me show you the question. A galvanometer of resistance 100 ohms. G is given as 100 ohms. Is used to measure 10 ampere current. So current in Ig is given as 10 ampere. Find the value of shunt resistance in parallel so that its range becomes 50 ampere. So current must be 50 ampere. Okay, range. This net current must be 50 ampere. Okay, we have to find the value of shunt. What did I tell? When it comes to the shunt, it is Ig into G upon I minus Ig. Now, Ig is given as how much? That is 10. G is given as how much? That is 100 upon I minus Ig. That is 50 minus 10. That is 40. This 0 and this 0. Now 100 divided by 4. That is 25 ohm. That's it. Take a look at this. You have got in an ammeter 0.2% of the main current passes through the galvanometer. If this is current I, 0.2 I flows through the galvanometer. How much is the rest? Rest will be 99.8 I that flows through this shunt. If the resistance of the galvanometer is G, the resistance of the ammeter will be, you have to find the net resistance of the ammeter. Before that, you find the shunt. Guys, let's find shunt first. Shunt will be Ig into G upon I minus Ig, simply. Ig in this particular cases, that is 0.2 I. Okay, into we say G upon I minus Ig. That is how much? I minus Ig is how much? 99.8 I. I and I will cancel. So you can say 0.2 I, that is 2 divided by 10, like this. 2 divided by 10, and that is G. 0.2 is 2 divided by 10. 99.8 we can write 998 divided by 10. This 10 and this 10 will cancel. 2 ones are 2, 4 99s are. So shunt comes out to be G divided by 499. Now we have to find the resistance of the ammeter. That is the net resistance. See guys, resistance of the ammeter. So here, instead of this, I would say this is galvanometer G. And how much shunt came out to be? This resistance is G divided by 499. Now these two resistors are in parallel. Now if you have to find the net of these two, how do you write? Equivalent resistance, that is R1 R2 upon R1 plus R2. So guys, in this particular case, if you have to find the equivalent resistance when the two resistors are connected in parallel, so we write this formula. So R equivalent in this case will be R1 R2. R1 is given as G, R2 is given as G divided by 499 upon, then we say G plus G divided by 499. So how much will be this? G square by 499. Then we say 499G plus G, that is 500G. 500G divided by 490. This and this will cancel. This G and square will cancel. So answer will be G divided by 500. G by 500 is the resistance. Okay, let's finish this one also. Conversion of galvanometer into voltmeter. If you have to convert galvanometer into ammeter, you connect shunt resistance in parallel. But when you have to convert galvanometer into voltmeter, voltmeter is a device which measures potential difference. Ammeter is a device which measures current. You connect the shunt resistance in series. This is called voltmeter. And how much is the value of shunt over here? This one. V divided by Ig minus G. V divided by Ig minus G. Take a look. A galvanometer has a resistance of G is equal to 100 ohms. Gives a full scale deflection of 30 milliampere. Means current in this is 30 milliampere. Okay, 30 milliampere you can convert. You can say 30 into 10 raised power minus 3 ampere. If it is to work as voltmeter of 30 volt range, you have to convert this into a voltmeter, which has got how much, which can measure how much voltage? 30 volt. The resistance required to be added will be shunt we are supposed to calculate. Shunt we are supposed to calculate. This is the shunt. V divided by Ig minus G. So shunt in this case is V divided by Ig minus G. So shunt will be, value of this is 30. V is 30 divided by Ig. That is 30 into 10 raised power minus 3 minus G, that is 100. 30, 30 cancel. 10 raised power minus 3 becomes 10 raised power plus 3 in the numerator. That is 1000 minus 100. That will be 900. So you have to connect 900 ohm resistance in series to the galvanometer. Then it can convert to a voltmeter, which will be having the range of 30. There is one more question. This I'll give you as homework. Okay. So I'll be coming up with one more session. Okay. One more session on 30th. Okay. So be ready for that, my dear friends. As of now, you have Wasim sir's session after this. Thank you so much. And guys, do let me know once I end the session. Do let me know in the comments how was the session. Okay. Do let me know in the comments how was the session. That's all for today. So thank you. Okay, take care and bye-bye. Huh? Do let me know in the comments how was the session and all. Take care. Take care.